So today what we're doing is right angle trigonometry. Now we're going to assume that A is the angle, and based on that BC is the opposite and AB is the adjacent and AC is the hypotenuse. And we'll just say opposite is BC and ADJ is AB. So now for C, now the adjacent ends up being BC and the opposite is AB and the hypotenuse ends up being AC. So using the angle C, that's what we get. Take a moment and copy. Now when we talk about trig ratios we're always using SOHCAHTOA for right angle triangles. So that means sine of theta is opposite over hypotenuse, cos of theta is adjacent over hypotenuse, and tan of theta is opposite over adjacent. So these are the ratios we have used before. Now, based on that, we're going to take a look at this triangle. Based on this triangle that we have here, we're using F as the reference. So the adjacent is EF and the opposite is ED and the hypotenuse is that. So now what we're going to do is we're going to show all the ratios for cosine, sine, and tan. And now based on that we're going to use our triangle and set up the ratios. So we're going to say the sine of F, the cosine of F, and the tan of F is going to be certain ratios of line segments. So the first one is DE over DF. For cosine of F, it's going to be EF divided by DF. For tan of F, we're going to have DE divided by EF. And now, our next problem asks us to calculate sine of 35, cosine of 52, and tan of 73 to 4 decimal places. When you do this, punch it in your calculator and write down the first 5 decimal places. Then what I want you to do is I want you to highlight the 4th decimal place and then look to see what number is to the right of that. For this one we have 5 and to the right of it is 7, so our final answer is going to be 0.5736. The same can be done for cosine of 52, and we're going to get 0.61566, and it goes on forever. And our 4 decimal rounding is going to be approximately 0.6157 because the last 6 has to force us to round up to a 7. Now, tan of 73 is 3.72085, and that goes on forever. And we're going to round that up to 3.2709 because in position 4, the next digit is 8. And I'm also highlighting that second one for cosine of 52. So we get 3.2709. Now, let's go take a look at our calculations for angles. In order to do that, we're going to say that the angle A is going to be the sine inverse of whatever that decimal was on the right side. So now we're going to have 0.2145. Now, in order to get sine inverse, what we have to do is use the second function or the shift and the sine function to get that to work. Now, make sure you try that. And when you get your final answer, you're going to end up with the final answer of 14 degrees. And notice, we're only coming out with the whole numbers for each of these. The same calculation can be done for B and C as well. And now we'll move on to the next problem. And the next problem will be dealing with side lengths. Taking a look at this triangle, we're going to assume that this is our B value is going to be our reference angle, which means that this is our opposite, and this is our hypotenuse, and this is our adjacent. When we write SOHCAHTOA, we're going to try and find the appropriate ratio. In this case, when we take a look at this, we're going to use SOH because we have the opposite here and the adjacent side here and the angle. And now, doing our appropriate substitutions, we get the following. Sine 38 equals x over 41. Now, once we've done that, all you have to do is add a 1 underneath sine 38, and now we're back to what we were doing before, which was cross multiplying. And we end up with this. 1x is equal to 41 sine 38. So now we'll simplify the right side, which is pretty easy. We end up with 1x is 25.2. Now we'll divide both sides by 1. And we get the following. X is 25.2 meters. Let's now take a look at example 4b. We're going to find the unknown side. In this case, the unknown side is x. And just like before, you're always going to use the reference angle as the angle that's given. And then you're going to use the opposite, adjacent, and hypotenuse sides. So we start with SOHCAHTOA. Now, which one would work? So we try sine. Sine is opposite over hypotenuse. That doesn't work. There's no opposite. We'll try cosine. So cosine is going to be adjacent and hypotenuse. Perfect. So we'll use that as our calculation. So now we have cos 23 is 13.2 over x. And we'll do the same trick that we did in the previous example. Put cos 23 over 1, and then we cross multiply. So now we have x times cos 23 is 13.2 because, well, if you take a look, 1 times 13.2 is an easy calculation, but x cos 23 is a decimal, but I'm just going to leave that for now. Now, in order to get rid of the cos 23, we're going to divide both sides by cos 23. And we get x by itself is equal to, once you punch that in the calculator, you're going to get 14.3 meters. Alright, so now let's move on to our final problem of the day. Find the angle marked A in the following triangles. So here we go. So let's go and reference the angle and label the sides. Now what we'll do is we'll write down SOHCAHTOA and figure out which one of these works. Taking a look at our problem, we've got two sides which are adjacent and hypotenuse, and we're just looking for the angle. So basically we're going to end up using TOA. So now we've got tan of theta is equal to opposite over adjacent. And we end up with something like this. So remember, 16.3 over 12.5 is the same as saying 16 divided by 12.5. But you'll also notice that we also include the brackets. When you put this in your calculator, make sure that you include the brackets. Otherwise, the calculation doesn't work. And in this case, when we calculate our final answer, we get A is equal to 53 degrees. Now, yesterday I said that I wanted you to do part B on your own, and I would write the solution up for you. And here it is. And we end up with the final answer of A is equal to 42 degrees. So, just a quick recap. basically when we do these problems, what we have to do is we have to identify the reference angle, then label all of the sides. Once we've labeled all the sides, we have to use SOHCAHTOA to figure out what ratio we're going to use. In this case, because we have the hypotenuse and the opposite, we're going to use sine. Now we do our appropriate substitution and then we calculate our final answer. Now remember, when you punch this in, you're going to either use the brackets or calculate this decimal first and then use sine inverse of whatever answer you get from here to get this final answer. It's up to you. Now, what I'd like you to do is I'd like you to do these questions that I have here. Page 13 and 14, number 1 to 8, and number 15, questions 9 through 12. Have a good evening. See you tomorrow.